This diagram illustrates the historical standard of perimeter-based defense, commonly known as the castle and moat architecture. When a user authenticates through a VPN gateway, the system assumes they belong there, granting blanket access based on implicit trust. But if an attacker acquires a valid username and password, they use the exact same VPN gateway, bypassing the perimeter firewall entirely. Once inside, the compromised connection travels unrestricted to internal servers and sensitive databases. This physical perimeter logic worked when servers sat in a corporate basement and employees worked at office desks. The mass migration to cloud computing, remote work, and software as a service stripped away those physical boundaries entirely. Implicit trust is an engineering flaw. It assumes a single initial login equals safety, making modern credential theft and supply chain attacks highly devastating. The structural solution to this flaw is an architecture built on a single, uncompromising rule: never trust, always verify. To implement this, we have to abandon the idea of a topological, geographic perimeter. Instead, the security boundary shifts to an identity-driven control plane. In this system, every single access request must continuously prove its context: who is asking, what device they are using, and where they are located, regardless of whether that request originates from a coffee shop or deep inside the corporate network. In modern distributed infrastructure, the network wall no longer exists. Identity is the only meaningful perimeter. Look at this model. We have an isolated user node on the left and a target data application on the right, separated by an empty void. This is how we engineer a secure transaction from first principles. The first mandatory checkpoint is identity verification. We intercept the connection line with strict identity and access management policies, requiring multi-factor authentication to prove the user is who they claim to be. Identity alone is insufficient. As a secondary filter layers in, we assess the device posture, ensuring the hardware itself is compliant, fully patched, and recognized by the organization. Finally, we evaluate the connection context. This analytical filter, locking into place, analyzes location, time, and behavioral patterns for anomalies before allowing the connection line to successfully reach the target application. This logic is applied at the workload level, a practice known as microsegmentation. Instead of guarding entire data centers, network boundaries collapse tightly around the individual target application to form a secure, isolated zone. Because of this continuous three-part checklist, even if a broader network is compromised, the individual resources remain isolated and secure. Zero Trust is a vendor-agnostic framework. To deploy it, you must translate these concepts into highly specific engineering implementations, depending on your cloud environment. Let's examine how this maps to Amazon Web Services, our first major cloud implementation. We can apply this exact same methodology to Microsoft Azure's proprietary cloud ecosystem. This comparative matrix breaks down the architecture into three planes: identity, network, and analytics. In AWS, the identity plane is governed by AWS IAM, utilizing specific IAM rules and policies to dictate exact permissions. At the network layer, AWS enforces microsegmentation using security groups for instance-level protection, backed by network access control lists for subnet-level boundaries. For continuous verification, AWS relies on CloudTrail to log every action, while GuardDuty provides the threat detection analytics to flag anomalous behavior. As the matrix wipes and replaces our AWS data, Azure's equivalent identity control plane steps in, relying heavily on Entra ID. Bridging identity and the network is conditional access. This is the primary engine in Azure that enforces risk-based authentication rules before granting entry to any resource. To complete the Azure matrix, Microsoft Sentinel functions as the SIEM, or Security Information and Event Management tool, powering continuous behavioral analytics. The proprietary tools and syntax differ completely, yet both AWS and Azure execute the exact same underlying zero-trust logic. Cloud-native software tools are critical, but they are insufficient for securing hybrid environments that still rely on physical network routing. To manage this, providers like Palo Alto Networks integrate next-generation firewalls into the zero-trust topology. Palo Alto abandons simple IP and port blocking. Instead, they inspect deep traffic context using App ID and User ID. They verify exactly which user is attempting to reach which specific application, regardless of the port they use. This integrates seamlessly with Cortex XSIAM, providing autonomous, continuous behavioral verification directly at the hardware level. Modern network hardware must inspect the identity and intent of a data packet, rather than just rubber stamping its geographic point of origin. This simulation shows how these components function in production. Watch as these red data nodes attempt to infiltrate a stable blue geometric cluster, representing a multinational bank's hybrid AWS and Azure environment. The attack vector is straightforward. A remote bank employee's legitimate login credentials are stolen and utilized from a new geographic location. A traditional VPN-only setup would blindly authenticate this malicious login because the password was correct. But under Zero Trust, the telemetry intervenes. The system immediately flags the anomalous geographic location and identifies the device hardware as unrecognized. Based on those risk flags, the conditional access policy automatically drops the connection, completely disregarding the valid username and password. And there is an ultimate failsafe. Even if the attacker bypassed identity checks via session hijacking, microsegmentation strictly prevents them from moving laterally to the financial databases. By treating every request with suspicion, Zero Trust successfully neutralizes compromised credentials, proving that mere authentication is entirely insufficient for access. The immediate future of this architecture relies on integrating artificial intelligence and machine learning to create autonomous security operation centers capable of instant threat response without human intervention. The industry is also shifting toward passwordless authentication, specifically passkeys, aimed at eliminating credential theft entirely from the equation. Building and defending these systems dictates specific tracks for cybersecurity professionals. Cloud security architects focus on designing the segmented infrastructure and the policies that govern it. Meanwhile, SOC analysts and threat hunters monitor the telemetry generated by continuous verification. This skill tree maps the abstract concepts of identity, network, and analytics to actual career requirements. Engineering these proprietary systems demands specific vendor certifications, such as the AWS Security Specialty, Microsoft Azure's AZ500, and the Palo Alto PCNSE. These skills are necessary because the most common failures that undermine these systems are configuration errors, over-permissioning users, establishing weak IAM roles, and leaving workloads unsegmented. Zero Trust is never a finished, turnkey software product you can buy off a shelf. It is a continuous, evolving engineering methodology.